This talk will explain a novel method for bispectral photometry using an event camera and modulated illumination. Spectrophotometry is an important tool for measurements of participating media. According to the Beer-Lambert law, the incident light into media is exponentially attenuated up to target parameters. Bispectral photometry is a type of spectrophotometry using two different wavelengths. Observations at both the wavelengths are individually amplified and then subtracted. The final result is called bispectral difference. Features versus the conventional method are that it can remove scattering effect and estimate relative values even in a mixture of media. The wavelengths need to be selected so that the difference in extinction cross-section of the target between the wavelengths is as large as possible. Bispectral photometry is often used for measuring a relative concentration in analytical chemistry. In atmospheric science, the bispectral difference allows to trace and classify particles and gases. In medical science, analysis of the bispectral difference is applied for determining the concentration of hemoglobin in blood. In computer vision, it is possible to reconstruct a 3D shape in a known medium, such as water, based on bispectral photometry. However, there are some drawbacks in conventional methods. Digital cameras are often employed for a spatial observation, but such device has drawbacks of low dynamic range and low quantization precision because of digital processing after observations, which are inherited by bispectral photometry. In order to solve those problems, we realized event cameras are key device. Event cameras are new device to asynchronously observe changes in brightness. Their features are high dynamic range, high temporal resolution, and low power consumption, which are preferred for fast camera tracking and reconstruction of high dynamic range and high frame rate videos. Each pixel in an event camera consists of a photoreceptor, a differentiator, and comparators. Received light is logarithmically amplified and then its temporal difference is calculated in the differentiator. Once the difference is over a threshold, an event is triggered as well as the difference is reset to zero. Note that accumulating the events enables to reconstruct the differential signal because of the fixed threshold. Here, we found an interesting analogy between the bispectral photometry principle and the event generating mechanism in an event camera. In order to directly connect them, it is required to convert the temporal difference in the event generating mechanism into the bispectral difference. So, we install temporally modulated illumination with bispectral light sources. The proposed method consists of a bispectral illumination module and an event camera. For example, when a modulation function is a triangle wave, another function also becomes a triangle wave shifted for a half of the period. The amplitudes are adjusted so that the total intensity of emitted light is always constant, but the total intensity of transmitted light temporally changes because of the difference in absorption. The event camera records events based on the temporal change. Finally, accumulating events allows to reconstruct the bispectral difference. In order to evaluate the proposed method, we built a prototype imaging system. In a reflection setup, 915 nanometers and 940 nanometers lasers are used as light sources. Illuminating a target whiteboard in a water tank, the event camera observes reflected light from the target. The target board is translated in water every 10 millimeters, and the numbers of recorded positive events are averaged for 100 times. In the range until 100 millimeters, the number of the events tends to be proportional to the distance. This shows the prototype works as well as the theory. We have evaluated our method through reconstructing depth images and compared with the existing method. The experimental results show that our method reconstructs the global shapes. The golf ball and stairs reconstructed by ours look more accurate. In further comparison, we pick up the stairs to evaluate the cross-sections of the shape, because the geometry is known. The results shows that our method allows to reconstruct a better 3D shape compared with the existing method using a conventional camera system. The bispectral difference can be used to reconstruct the concentration of a medium in mixture solution. In a transmission setup, we replaced the light sources into 637 nanometers and 850 nanometers lasers. A target is a mixture of water and soy sauce whose concentration is changed every 10%. Even though high dynamic range images are used for the existing method, our method works for a higher concentration and is more accurate. Let us conclude this talk. We proposed event-based bispectral photometry to obtain a bispectral difference image using an event camera with temporally modulated illumination, based on the analogy between the bispectral photometry principle and the event generating mechanism. The design of a modulation allows to read out the bispectral difference directly as the number of events. Finally, we verified the feasibility of the novel usage of event camera in photometry-based vision tasks. Thank you.